Okay, so you sent us this
Yep.
2025 European Deep Tech report.
Right.
And wow, there is a lot to unpack here.
Yeah, there really is.
We thought we could
Absolutely.
try to like distill it down to the most important things.
Really key takeaways.
Yeah, the key takeaways so that our listeners can get a quick overview
Right.
without having to wade through all of this.
Yeah.
Um,
It's pretty dense.
it's dense, yeah.
Long report.
So
yeah.
what is it trying to do? Like, what's the point of this report?
So it's trying to establish a common language around deep tech in Europe,
Okay.
and kind of clear up some misconceptions about what deep tech is, what it isn't,
Yeah.
and really focus on the areas that are driving innovation in Europe right now.
Okay.
It's supposed to be an overview
Yeah.
of a really dynamic field.
So it starts with the basics, like just defining deep tech,
Yeah.
what that even means.
Exactly.
Then it talks about like what makes Europe uniquely
Yeah.
positioned to be a player in this,
For sure.
and then where the money is flowing.
Right.
Like what are the investment trends?
Yeah.
And then it really drills down
Exactly.
into all these different segments like
Right.
novel AI,
Yeah.
the future of compute, space tech,
Absolutely.
novel energy,
Novel energy, yeah.
resilience,
Resilience.
computational biology and chemistry,
Oh my God.
That's a mouthful.
There's a lot here.
and robotics.
Robotics, yeah. Okay. Yeah. A lot of stuff.
And there's even a section at the end
Right.
for founders.
Yeah.
So like
Okay,
people who
that's
want to
right.
start deep tech companies.
Yeah.
Which we might touch on a little bit.
We should.
Yeah.
Yeah, we should definitely.
Just to kind of give a flavor of
Yeah.
the really practical advice that they're offering.
Uh-huh.
But before we dive into all of that,
Yeah.
there's a really important kind of methodological point that they make at the beginning.
Yeah.
And I think it's really worth highlighting.
It is.
You know,
worth calling out.
Yeah, which is basically that the definition of deep tech is not static.
No, it's not fixed.
Right. So things that might have been considered like
Bleeding edge.
bleeding edge, cutting edge
Absolutely.
3 years ago or 5 years ago.
Like LLMs.
Like LLMs are now becoming mainstream.
Right. Yeah.
So they're not necessarily
Exactly.
highlighted as much in this report as they might have been
Right.
in a previous report.
Correct.
And that also kind of explains why some of the funding figures
Yeah.
might fluctuate from year to year.
Absolutely.
Right. So it's
Also-
not always a direct
No, it's not always apples to
apples comparison.
Right.
Okay.
Yeah.
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 So we should also mention that like this isn't just some
Yeah.
random report that like
Gee.
someone put together.
It's pretty well researched.
Yeah, it's actually based
Good
on the
stuff.
insights of some really impressive people.
Like some real heavy hitters.
Yeah, like they've got investors
Right.
like Tony Fadell.
Who's that? Just for our listeners.
Yeah, so Tony Fadell was the guy who
Oh, okay.
um,
I've heard of them.
created the iPod
Yeah.
and the iPhone at Apple.
Very cool.
And then they've got Herman Hauser,
Okay.
who is like a legendary
Yeah.
venture capitalist in Europe.
Uh-huh.
And then Billant Alton from Early Bird Venture Capital.
Okay.
So these are people who are like really on the ground,
Yeah, actually writing checks to these companies.
writing checks to these companies. Yeah.
Yeah.
And then they've got leading academics
Oh,
like
really?
David Baker,
Okay.
who's done groundbreaking work in protein folding,
Oh, wow.
and Reinhard Heckel, who's at the Technical University of Munich.
Okay. Cool.
And then even like industry titans
Oh, wow.
like Peter Wenink from ASML.
I don't know that one.
So ASML is like the biggest
Okay.
semiconductor equipment manufacturer
Okay.
in the world.
All right.
So they're the ones who make
Got it.
the machines that make the chips.
Oh, wow. So,
Yeah.
yeah, heavy hitters.
Yeah. So it's a really diverse
Absolute.
perspective.
Yeah.
And they're drawing on
Yeah.
all of their experience
Cool.
and their insights.
Sure.
So let's
Yeah.
dive in.
Let's get into it.
Yeah. So how do they define deep tech?
They say it's novel science shipped in a first-of-its-kind product.
Okay.
It sounds kind of simple,
Right.
but it's actually a really powerful, ambitious.
Succinct, but also powerful. Yeah.
Yeah.
Because it highlights like the foundational role
Absolutely.
of scientific breakthroughs.
Yeah.
So it's not just about like,
Right.
you know,
Incremental improvements.
incremental improvements to existing technology.
It's like something brand new.
It's like something totally new.
Yeah.
Yeah. Okay. And so they talk about, what makes Europe a unique place for this.
Yeah.
And they really emphasize
Uh-huh.
the strength of
It's university.
its universities and its research institutions.
Exactly. Europe has got something like 40%
Oh, wow.
of the world's top 10 research institutions.
Really?
Yeah.
Okay.
Which is a huge number.
Yeah.
Yeah, and Germany and France are particularly strong in this area.
Okay.
Largely thanks to like consistent public funding in scientific research.
Right.
Yeah.
Okay, so there's a strong foundation there.
Yeah, absolutely.
Yeah.
They give some pretty good examples from the Times Higher Ed
Okay.
rankings from 2024.
Okay.
They looked at computer science and engineering, and you see like Oxford, ETH, Zurich, Cambridge, right up there on the top.
Yeah, those are some of the best schools in the world.
Absolutely.
Yeah.
Yeah.
And then they talk about like the spin-out value
Spin-out value, exactly.
from these universities.
So like how much are the companies that are spinning out of these universities worth?
Worth and Oxford, ETH, and Cambridge are
It's
again
at the top?
at the top there.
Yeah.
But then there's a little wrinkle here,
Oh.
which is that
Okay.
comparing spin-out numbers across Europe
Yeah?
is actually kind of tricky
Okay, why is that?
because
Yeah.
different countries have different policies.
Oh, okay.
So, for example, in France and Sweden,
Mm-hmm.
there's this thing called professor's privilege,
I've never heard of that.
where basically the universities don't automatically take equity in,
Interesting.
Okay. research innovations.
Okay. Okay. So it's harder to track.
Yeah, it's harder to track.
The spinouts.
Yeah, it makes it hard to compare like directly with the UK, Germany, Switzerland,
Right.
because they have
It's a different system.
systems. Yeah.
Okay. Yeah.
So,
Yeah. Makes sense.
they also look at the international patent landscape.
Okay.
So they look at like
Patent.
the top percentile of patents filed
Yeah.
by the technology area.
Uh-huh.
And what's interesting is they look at it from like 2010 to a projection for 2025.
Okay.
And there's a lot of growth,
Uh-huh.
especially in med tech and life sciences.
Okay.
So
Fantastic.
this kind of shows that like Europe is a hotbed of innovation.
Yeah, they're doing a lot of research,
Yeah.
filing a lot of patents.
Yeah, but they also kind of caution
Okay.
that Europe needs to fight for its share
Uh-huh.
of the global market.
Right. So it's not enough to just file patents. You have to actually
Yeah, it's not enough to just have the ideas.
Right.
You have to actually like commercialize them.
build companies.
Build companies.
Yeah.
Yeah.
Or
Okay.
market.
All right. Let's talk about money.
Okay.
So,
The lifeblood
yeah, the lifeblood
of startups.
of startups. Yeah.
Absolutely.
So they address this question.
yeah. Of whether deep tech companies just need more capital
Yeah.
than,
Regular company.
regular tech companies. Yeah.
SaaS companies, whatever.
Yeah. And their reasoning is actually
Makes sense when you think about
pretty logical.
what these companies are actually doing.
Yeah. Yeah.
So you think about it like
Deep tech
often involves
building stuff.
building stuff. Yeah.
Like physical infrastructure.
Physical infrastructure.
Right.
Like factories.
Yeah.
Satellites.
Satellites, yeah.
Like Starlink.
Yeah.
Like these are expensive things to build.
Yeah.
Gigafactories for batteries.
Yeah. Yeah. So they need a lot of money up front.
They need a lot of CapEx.
Yeah.
Capital expenditure
Yeah,
to just get going.
Yeah. And they contrast this with, a typical SaaS company where
Yeah.
a lot of the funding goes to
Sales and marketing.
sales and marketing. Yeah.
Advertising.
Advertising.
Okay.
Yeah, because like the barriers to entry are so low
Yeah, anyone can just start
for software.
a software company.
Yeah.
So
But with deep tech,
you have to build something first.
yeah, and that
It takes a lot of money.
that physical infrastructure becomes like
A competitive advantage.
like a moat,
A moat. Yeah.
hard to replicate.
Hard to replicate. Yeah.
Yeah.
Okay.
Yeah.
So then they look at like how quickly these companies
Hot
progress
stuff.
through funding rounds.
Yeah.
So like their conversion rate.
Conversion rate, yeah.
And interestingly, they found that
Right.
in the early stages.
Yeah.
So like from seed to Series B,
Right.
deep tech conversion rates
Yeah.
are actually comparable
Okay. How is it
to
regular tech?
regular tech. Yeah.
Sometimes even a little better?
Sometimes even a little better.
Interesting.
Yeah.
Okay.
So like the initial momentum
Right.
might be similar.
Yeah.
But the crucial insight is
Right.
what happens after that,
Yeah.
Series C and beyond.
Yeah. So deep tech companies typically need
Longer timeline.
longer timelines and more
capital.
More capital. Yeah.
To really get to that point
Yeah.
where they can scale.
To validate their technology, basically.
To prove that it actually works.
Yeah.
And to get it out there.
Yeah. And they say that only like 5%
5%.
of deep tech startups make it from seed to Series C+.
That's rough.
Yeah. So that's a pretty
Yeah, that's a big hurdle.
big hurdle, yeah.
Yeah.
And then kind of counterintuitively,
Right.
they also point out that failure rates are actually pretty similar for deep tech and regular tech.
Okay, so more money.
Yeah, so more money doesn't necessarily...
Doesn't mean you're going to succeed?
Guarantee success, yeah. Okay.
Interesting.
So they talk about some case studies of some prominent European deep tech companies like Northvolt
and Graphcore.
What do those companies do?
Yeah, so Northvolt is building these massive battery factories.
Oh, cool. For like the gigafactories?
Yeah, it was the gigafactories, yeah.
Wow.
And so they learned some really valuable lessons along the way.
Yeah. What were some of the takeaways?
For Northvolt, they really emphasized the importance of having a clear MVP.
Minimum viable product.
Yeah, so like you can't try to do everything at once.
Right.
You have to really focus on like
on one thing.
What's the core thing that you're doing.
Okay.
They also learned about like the dangers of taking on too much debt.
Oh yeah.
So like
don't over leverage.
Don't over leverage, yeah.
Yeah.
And they talked about the importance of building a resilient and ambitious company culture.
Okay, so like the people are important.
Yeah, the people are really important. Yeah.
Yeah.
And staying really focused on the core business.
Not getting distracted.
Not getting distracted, yeah.
Okay.
And also realizing that like the standard venture capital playbook might not be right.
Right.
For asset-heavy businesses.
Okay, interesting.
Yeah.
Okay.
And then for Graphcore.
What was their deal?
Yeah, so Graphcore was trying to revolutionize computing with their intelligence processing unit. And
so they're like competing with...
They were competing with NVIDIA.
NVIDIA, yeah.
Which is like the 800-pound gorilla in that space.
Yeah.
And so a major realization for them was that if you're going to challenge an incumbent, like NVIDIA, your product needs to be...
way better.
Way better. Yeah, not just...
like 10x better.
Yeah, 10x better.
Not just like a little bit better.
Not just incrementally better.
Right, you have to be game-changing.
Yeah.
Okay.
Like, being as good is not good enough.
That's a good quote.
Yeah.
Yeah.
And they also kind of made the mistake of setting a really high initial valuation target.
Which didn't really
pan out. And they ended up getting acquired for much less than they were initially hoping for.
Ouch.
Yeah.
That hurts.
Yeah. Okay. So then the report provides all this data on average round sizes for European deep tech versus regular tech. And this is like from 2023 to 2024. Across different stages.
Yeah.
And what's really interesting is they also look at the average funding needed to reach revenue milestones. So like $1 million, 10 million, 25 million, 100 million plus. And you can really see that deep tech companies generally need
more money. To
achieve those same revenue levels.
Yes, makes sense.
And then they look at the broader funding trends. And we've seen a general cooling off since the peak in 2021.
Oh, yeah, like across the board.
Across the board, yeah. So growth stage, early stage, late stage.
Right.
Although growth stage has shown some signs of life recently.
So things might be picking back up a little bit.
Yeah, maybe a little bit, yeah. And then they look at deep tech VC funding by country in Europe for 2024. And the UK is leading the pack.
No surprise there.
Yeah, no surprise.
Yeah.
Followed by
France
and Germany.
The usual suspects.
Yeah.
Yeah.
But it's interesting to see how the year-over-year growth rates are different.
Okay. So some countries are...
Yeah, some countries are growing faster than others.
Growing faster, yeah.
Yeah.
Interesting.
And then for those who are wondering, like, where's the action?
Yeah.
The main deep tech hubs.
Where should I go?
Yeah. London. Yeah. Paris. Munich.
Okay. Yeah.
Stockholm.
Cool. Those are the spots.
Those are the spots, yeah. And then what's really encouraging is the amount of funding that's going to specific deep tech areas.
Okay.
So they talk about novel deep tech segments.
Yeah.
Reaching $7.8 billion.
Wow.
Which is a 56% increase.
That's huge.
Yeah. So this is where the investors are seeing
the growth.
The growth potential.
Yeah. And then
they list some European deep tech unicorns.
Unicorns.
Yeah. So companies.
A billion-dollar company.
Billion-dollar companies, yeah.
Yeah.
Like BioNTech.
BioNTech.
Yeah.
What do they do?
They're in the biotech space.
Okay. Mistral AI.
Mistral AI, I've heard of them.
Yeah, they're in the novel AI space.
Yeah.
Dark Trace.
Dark Trace, cybersecurity.
Yeah, cybersecurity.
Yeah.
And Quantinuum.
Quantinuum, what are they?
They're in the future of compute.
So these are just examples of the kinds of companies that are being built.
In Europe.
In Europe, yeah.
Yeah.
Okay.
Okay, so let's get into some of these specific
let's do it.
Areas.
Let's dive into the segments.
Yeah.
Okay, so novel AI.
Okay.
They make this really important distinction that
novel
AI is not just applied AI.
No.
Right?
It's something different.
It's something different.
Yeah.
It's about like
new math.
Yeah, like fundamentally new algorithms.
Yeah. So they actually...
It's like the frontier.
Yeah. It's like the bleeding edge.
But AI.
Of AI, yeah. And so they kind of remind us of like the hierarchy of AI.
Yeah.
So
neural network.
Neural networks are a type of architecture.
Okay.
Machine learning is a broader field where systems learn from data.
Okay.
Deep learning uses...
Deep neural networks.
Deep neural networks.
Right.
And then novel AI. It's like
the next level.
Yeah, like creating entirely new
approaches.
No,
okay.
Cool.
So
novel AI.
What are the big trends?
Yeah, what's going on?
Yeah.
What are the hot areas?
So the specialization of large language models is a big one.
LLMs.
Yeah. So LLMs are being fine-tuned for like specific industries.
Yeah.
Like healthcare, material science, robotics.
Yeah.
And that's making them
way more useful,
way more effective.
Yeah.
Yeah.
Makes sense.
And then there's this growing emphasis on reasoning.
Oh, yeah.
So
making AI.
Yeah. Like, can we make AI
smarter,
more logical?
More logical.
Yeah.
Yeah.
And there are all these different techniques.
Like what?
Like reinforcement learning.
Oh, okay.
Where AI agents learn.
Run by doing.
Through trial and error.
Yeah.
And then there's
chain of thought prompting.
Yeah. Where you kind of encourage the models to
think step by step.
Yeah, to explain their reasoning. Right. And that makes them more transparent.
Yeah. More understandable.
Yeah, more understandable.
Yeah.
But turning this novel AI into actual businesses is proving to be a bit of a challenge.
Okay, why is that? Yeah. It's like you build the infrastructure, but...
Yeah, they make this interesting analogy to the early days of the railroad industry.
Okay.
So, like...
You lay down the tracks and then...
Yeah, you lay down the tracks and then you're like... Well, what are we going to transport on these tracks?
Right. Are people actually going to use this?
Yeah.
Yeah.
So there's this question of like...
Yeah.
Okay, we have this amazing technology, but what...
What commercially viable?
Yeah, the commercially viable application.
The use cases.
The use cases, yeah.
Yeah.
And then there's this whole debate about open source versus closed source.
AI models.
Yeah. And open source models are rapidly improving.
Right.
Which is kind of...
Which is good and bad.
Good and bad, yeah.
Yeah. It depends.
Yeah, it depends
on your perspective.
Your perspective.
Yeah.
And then there's this emergence of AI agents.
Oh, yeah.
Which is really interesting.
Yeah, that's pretty cool.
There's an autonomous system.
Autonomous AI systems.
They could do stuff.
Yeah, they can do stuff.
Yeah. It's pretty cool.
And they give the example of...
OpenAI's operator.
Yeah. Which is...
Like an AI agent that can...
Yeah, it can kind of like do things...
Do things for you.
Do things for you, yeah.
Yeah.
So this kind of raising questions about like the future of APIs, like how are we gonna
interact with AI?
Interact with these AI systems going forward.
Yeah.
Yeah.
Interesting. And then of course we can't ignore the massive amounts of money.
The CapEx.
The CapEx, yeah, is pouring into AI.
This is crazy.
So they talk about initiatives.
Yeah.
Like what Trump has proposed.
Oh yeah. And Altman's
like
crazy fundraising
efforts, yeah.
Yeah.
And then like BlackRock and Microsoft are investing in data centers.
Huge data centers.
Yeah. So the assumption is more data equals better models.
Better models.
Yeah.
Yeah.
But current AI models still lack a fundamental understanding of the
physical world.
Yeah.